A huge mystery that arose from Jupiter with the Voyager missions was the thermal issue I talked about in the previous lecture. But the other thing that actually arose with the pioneers, and Voyager confirmed it, was Jupiter's magnetosphere, which was not like anything we'd seen before, because Jupiter's magnetic field is one of the strongest magnetic fields in the entire solar system, other than near sunspots. It's way stronger than Earth's magnetic field. And that means that the radiation belts around it, kind of like the Van Allen belts around Jupiter, around Earth, are going to be vastly more intense. But Jupiter rotates much, much faster than Earth. And so the magnetosphere is much bigger, and so what happens is that these Van Allen belts are going around Jupiter so fast that you can think of it as centrifugal force flattening it out to like a disk around Jupiter. And so that makes what we call a current sheet, because all these charged particles are whipping around Jupiter like a charged ring around Jupiter, a ring of charged particles. And so that produces this massive radiation zone, and then other particles are going back and forth along the magnetic field lines between there and Jupiter. And so we have this incredible, intense radiation field around Jupiter. In fact, they never dreamed it'd be that intense. This is far more intense than anything they'd ever seen. And so the pioneers just barely, just went through here pretty quick, and they weren't very effective. But they realized that the Voyagers, which would be passing pretty close here, would be pretty well at risk, and so they had to actually shield the electronics against the electromagnetic pulse here. They furthermore had to consider this with the Galileo spacecraft. Galileo really wanted to study some of the moons of Jupiter that were up close to Jupiter, but it really didn't get a good view of them because it spent so much of its time orbiting farther from Jupiter. Every time it dived in an orbit close to Jupiter turns out to be a risk to the spacecraft because of the high radiation environment. Even though they had armored it against the radiation, it can only do so much. And so this was a huge shock. The solar wind bounces off the front of the magnetosphere, the magnetopoles, that creates a big shock wave there, a bow shock around there. So yeah, that's the second massive zone of radiation a spacecraft going to Jupiter has to deal with. Just getting close to Jupiter, when you hit that magnetosphere, you have this massive bow shock and a blast of radiation, and then you get up close to Jupiter, and again, these incredible radioactive environment. One of the things we look at are the moons of Jupiter, and I should point out those moons can be down in that high radiation environment, which makes actually, one of the things we sometimes ask about is, okay, are planets habitable? But the other question, are moons habitable? In Jupiter, this is something that really needs to be considered, is that those moons are in a high radiation environment. Does that affect the habitability? Jupiter's magnetosphere is 30 million kilometers across. It is so huge that if you could see it, if you could actually see that with your naked eye, it would look about 16 times bigger than the full moon does in the sky. From as far away as this is 4 AU away from us. It would still be this monster sort of thing in the sky. Jupiter dominates the solar system. Jupiter dominates the solar system with its size. Jupiter dominates the solar system with its gravity. Jupiter dominates the solar system with its magnetic field and magnetosphere. The radiation around there, all these particles slinging around actually produce radio waves. Jupiter produces more radio waves than anything else in the solar system. If you were a long ways from the solar system, science fiction, hey, people can hear our radio broadcast. Well, really, Jupiter broadcasts louder. And so we broadcast different frequencies, so that might make a difference, but Jupiter actually is the louder signal. And so it stands out. It's the strongest magnetic field in the solar system of all the planets. Very large array looking at some of the wavelengths of radio waves coming from Jupiter, and you can see where that magnetosheath is or around Jupiter, and then some of the particles, going back and forth between Jupiter and the magnetosheath. So you can actually image this. Like I said, it gives off enormous amounts of radio waves. All these particles also slamming into Jupiter's atmosphere create an aurora. Earth is not the only planet with an aurora. We don't talk about an aurora with Mercury because the magnetic field is weak and there's really no atmosphere to interact with. Yeah, we talked about a little bit of sodium, but it's not really a true atmosphere. Venus has no appreciable magnetic field, so there's no aurora. Mars has no appreciable magnetic field, so no aurora. Earth has a magnetic field, so we get an aurora. Jupiter has a supersized magnetic field, so we expect supersized aurora. In fact, the auroral ovals on Jupiter are incredibly impressive. There are essentially like millions of amps of current slamming into Jupiter there, actually producing this. Again, very large array picture of Jupiter up at the top. The little dashed line shows you what Jupiter would look like, and then the VOA imaging where the radio signals are coming from, and that's mapping out this radiation environment, because all those particles slinging around produce radio waves, something that we call cyclotron radiation or synchrotron radiation. When they slam into Jupiter's atmosphere, you get the auroral oval that you see below. And these auroras are permanent. They don't wax and wane all that much. These are like permanent auroras, displays here from all these particles slamming into Jupiter's atmosphere. Jupiter does have rings. We don't really think about it, but the Voyagers, as they flew past, took pictures on the back side of Jupiter looking back at it, and on the left there is an image of one of those rings sent back by one of the Voyagers. And this was a shock. Turns out these rings are composed of fine dust grains, possibly kicked out by meteorite impacts from some of the inner moons. And so that's one speculation there. These dust grains make for dark rings. They don't reflect a whole lot of light. They're not very big, and they've never really been seen from Earth because they are so small and so dark. You can see them from the orbit of Jupiter when you get there, but not from Earth. So this was a huge surprise. I remember when this discovery was happening, I was in graduate school, and we had a sort of a big map of the solar system in the lab room. And some of the students there decided that what we were going to do is take a pen and draw a ring around Jupiter, because the only one that had rings marked on it was Saturn, because Saturn's rings stand out and you see them from Earth even with a little tiny telescope. But now we have rings on Jupiter, even though they could not be seen from Earth. Later, we discovered that there were rings around Uranus and also around Neptune. So it turns out that all of the gas giants have rings. Only Saturn's rings are the really prominent, bright ones. But the other planets do have rings as well. Rings around Jupiter have dames here. They are very close in, near some of the innermost moons of Jupiter.